Hello dear students, welcome to mathematics class. In this class, let us discuss some more examples on the Cauchy's integral formula and Cauchy's integral formula for derivatives. So the first example of today's class is integration over c e power 3z divided by z cube dz over the circle c such that mod z equal to 1. So here this integral is of the form integration over c f of z divided by z minus a whole power n plus 1 into dz, because here the power of z is more than 1. So whenever the power of z is more than 1, then we are going to use the Cauchy's integral formula for derivatives. So if the power of z is 1, then only we are going to use the Cauchy's integral formula. So here it is z cube, and this can be written as z minus 0 whole cube, right? So if the denominator is of the form z minus a whole power n plus 1, then we need to use the Cauchy's integral formula for derivatives, or if it is only z minus a, then use the Cauchy's integral formula. So here its value is given by 2 pi I divided by n factorial f power n of a. So here f power n means it is the order of derivative of the function f with respect to z. Then let us consider the given integral and compare these two integrals. Then f of z equal to e power 3z and z minus a is equal to what? Z minus 0. It implies that a is equal to 0 or 0 comma 0, and in place of n plus 1 we have 3. So here n plus 1 equal to 3, it implies n is equal to 2. So now we got f of z and the point a, which is 0 comma 0, and the value of n, which is equal to 2. So here given circle is mod z equal to 1. So it implies that center, so let us denote the center by z naught. So z naught is equal to 0 comma 0 here, because it is z minus 0, where that 0 represents the center of the circle, because we know that the equation of the circle is given by z minus a is equal to r. So here a is the center of the circle and r is the radius of the circle. So therefore in the given circle a is equal to 0, hence the center z naught is equal to 0 comma 0 and radius is equal to 1. And now we need to check whether the given point lies inside the circle or outside the circle. If the point lies outside the circle, then the value of integral is directly equal to 0. If it is inside, then only we have to evaluate the value of the integral. So here the given point is 0 and the radius of the circle is 1. So here whenever radius of the circle is 0 comma 0, then we can directly go for the point A. So if the center is other than 0, then we can use the distance formula to find the distance between the center A and this z naught. So here since z naught equal to 0 comma 0, then no need to find the distance between z naught and the point A. So therefore here already we know that a is equal to 0 and 0 is less than 1. So therefore the point lies inside the circle. So here a is equal to 0 lies inside the circle mod z equal to 1. So therefore integration over c e power 3z divided by z cube dz equal to, now put the values of n and a in this formula. So this is 2 pi I divided by n factorial, that is 2 factorial, and f power 2 of a. f over 2 means we need to differentiate f of z with respect to z 2 times. So here f of z equal to e power 3z, then f dash of z equal to 3 into e power 3z, and f double dash of z equal to, so 3 into 3, that becomes 9 into e power 3z. So here we know that a is equal to 0 means f double dash of 0 equal to 9 into e power 3 into 0, which is equal to 9. And then integration over c e power 3z divided by z cube dz equal to 2 pi I divided by, so 2 factorial is 2, and f power 2 of a, that is equal to what? 9. So 2 and 2 get cancelled, it is equal to 9 pi I, which is the required value of the integral. So here whenever the center 0 comma 0 is given, no need to find the distance between a and that center. So if the given center is other than 0, then only find the distance between those 2 points. Otherwise, just by looking at the value of a, we can say that whether the point lies inside or outside the circle. If a is greater than the radius, then the point lies outside. If a is less than the radius, then the point lies inside the circle. The next example is evaluate the integration over c z square plus z plus 1 divided by z minus 2 whole cube dz. So here also see the denominator. So denominator is of the form z minus a whole power n plus 1. So therefore we are going to use the Cauchy's integral formula for derivatives. So therefore first compare this integral with the standard form, that is integration over c f of z divided by z minus a whole power n plus 1 dz is equal to what? 2 pi I divided by n factorial f power n of a. Now f of z, that is equal to what? Z square plus z plus 1, right? And z minus a is equal to z minus 2, it implies a equal to 2 or 2 comma 0, means it is a complex variable with real part 2 and imaginary part 0. So that's why, so in the form of ordered pair, we can represent that as 2 comma 0. Then the value of n, so here n plus 1 equal to 3, then it implies n equal to 2. So here we got f of z, the value of a and the value of n, and the given circle is mod z equal to 3, right? So now the center of the given circle can be considered as z naught, which is equal to what? 0 comma 0, because here z minus z naught or z minus a, that is the center of the circle. So we are representing that center of the circle as z naught, which is equal to 0 comma 0, and radius is equal to 3. So again here the center of the circle is 0 comma 0, then no need to find the distance between the center and the given point. So just look at the value of a. So here the value of a is 2 and the value of r is 3. So hence that 2 is less than 3, hence the point lies inside the circle. So here 2 less than 3, it implies the point lies inside the circle mod z equal to 3. So therefore here integration over c z square plus z plus 1 divided by z minus 2 whole cube dz is equal to 2 pi I divided by 2 factorial, because n equal to 2 here, 2 factorial into f double dash of a, and a is equal to 2. Then we need to find this one. So now f of z equal to z square plus z plus 1, then f dash of z is equal to what? 2z plus 1, and f double dash of z equal to 2. Then it implies that f double dash of 2 equal to 2 only, because it is a constant function which is independent of z. So therefore we can directly consider that as the 2, since it is the constant function. So therefore here integration over c z square plus z plus 1 divided by z minus 2 whole cube dz is equal to 2 pi I divided by 2 factorial, which is equal to 2 into 2. So therefore its value is 2 pi I. So it is the way to apply the Cauchy's integral formula for derivatives. If you want to apply the Cauchy's integral formula only, here the power of z minus a should be is equal to 1. Then this becomes f of a instead of f power n of a, and here n factorial will be is equal to 1. Since n is 0, so 0 factorial is 1. The next example is integration over c e power pi z divided by 2z minus I whole cube dz, such that c is the circle, mod z equal to 1. So here the given integral is not in the standard form, because our integral will be must be of the form integration over c f of z divided by z minus a whole power n plus 1 into dz, which is equal to 2 pi I divided by n factorial f power n of a. So in this integral the coefficient of z is 1, right? But in the given integral the coefficient of z is 2. So therefore it is not in the standard form. So therefore we need to write the integral in the standard form, then only we can find the value of a, f of z and n plus 1. So therefore here integration over c e power pi z divided by 2z minus I whole cube dz. So it is integration over c e power pi z divided by, here we need to take this 2 common or outside the function. Here cube is there, then that becomes 2 cube, then it is z minus I by 2 whole cube dz. So therefore it is 1 by 8, because 2 cube is there. Then integration over c e power pi z divided by z minus I by 2 whole cube dz. So now we can find the value of a. Now in this integral f of z is e power pi z, then z minus a is equal to what? Z minus I by 2. It implies a equal to I by 2, and the coordinates of this 0 comma 1 by 2, because here it is only imaginary part is given, that is I by 2. So therefore it is real part is 0 and its imaginary part is 1 by 2, hence it is x comma y, where x is the real part and y is the imaginary part. So therefore that becomes 0 comma 1 by 2, and value of n. So here n plus 1 is equal to what? 3, then n is equal to 2, and the given circle is mod z equal to 1. It implies that z naught equal to 0 comma 0, since the center of this circle is 0 comma 0 and radius is equal to 1. So here the value of a is equal to what? I by 2 means 1 by 2, right? So 1 by 2 is less than 1, therefore the point lies inside the circle. So here 1 by 2 is less than 1, it implies that the point means the value of a lies inside the circle. Therefore integration over c e power pi z divided by 2z minus I whole power 3 dz is equal to what? 1 by 8 as it is. Then this integral value is equal to what? 2 pi I divided by 2 factorial f double dash of a, and a is I by 2. We should consider a is equal to I by 2, not 1 by 2, because this is the ordered pair, that is a Cartesian form of that point. Then here f of z equal to e power pi z, f dash of z equal to pi into e power pi z, and f double dash of z equal to pi square e power pi z. Then put z equal to I by 2. F double dash of I by 2 is equal to pi square into e power pi I divided by 2. Then it is pi square into, so e power I theta, that is cos theta plus I sin theta. So we know that cos pi by 2 is 0 and sin pi by 2 is 1. So therefore it is 0 plus I into 1. The total becomes I only, then it is I pi square. So now simplify this one. Here 1 by 8, this 1 by 8 is here, right? And we are applying the formula only for this integral, that 1 by 8 will remain as it is. Then it is 2 pi I divided by 2 factorial is 2 into I pi square. 2 and 2 get cancelled, I into I, pi I square, and I square is minus 1. So minus pi into pi square, that is pi cube divided by 8. So it is the value of the integral, that is minus pi cube divided by 8. The next example is integration over c 2z plus 1 divided by z square plus z minus 6 dz over the circle C such that mod z equal to 4. So here the integral is 2z plus 1 divided by z square plus z minus 6, means the denominator is not in the standard form, because the standard form of that denominator should be z minus a, that should be linear factor of z. So but in denominator you don't have any linear factor of z, so therefore we need to reduce that to the factors of z. So now here first consider that z square plus z minus 6. So it is a quadratic equation. So already you know how to factorize the quadratic equation. So after factorization, here we have two factors, z plus 3 and z minus 2. Then here that integral becomes integration over c 2z plus 1 divided by z plus 3 and z minus 2 dz. But now in Cauchy's integral formula, or in Cauchy's integral formula for derivatives, there is only one factor in the denominator, right? Because here integration over c f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I divided by n factorial f power n of a. So here in denominator there is only one factor, but here we have two factors. Then we need to separate the factors, means denominators. For that we have to use the partial fraction. So already you are very familiar with those operations, that partial fraction. So here consider 1 divided by z plus 3 into z minus 2, which is equal to a by z plus 3 plus b divided by z minus 2. So then here the value of a is equal to minus 1 by 5 and b is equal to 1 by 5. Then 1 divided by z plus 3 z minus 2 is equal to minus 1 divided by 5 times z plus 3 plus 1 by 5 into z minus 2. Now this term becomes minus 1 divided by a linear factor of z plus 1 divided by a linear factor of z. Then we can apply the Cauchy's integral formula for these two functions. Then here integration over c 2z plus 1 divided by z plus 3 into z minus 2 is equal to. So here this can be written as, the numerator will remain as it is, that is 2z plus 1 only. So therefore integration over c 2z plus 1 divided by, put the term, here it is minus 1 is there, so therefore I am writing minus here, and 5 divided by z plus 3 plus integration over c 2z plus 1 divided by 5 into z minus 2 dz. Then it is minus 1 by 5 constant, writing outside, then integration over c 2z plus 1 divided by z plus 3 dz plus integration over c 2z plus 1, here 1 by 5 we can write outside, z minus 2 dz. Now consider the functions separately, then find the value of that one. Now consider this as equation number 1. From the equation 1, consider the first integral, that is integration over c 2z plus 1 divided by z plus 3 dz. So here the value of a is equal to what? Minus 3. So here we are going to apply the Cauchy's integral formula. Here Cauchy's integral formula for derivatives is not applicable, because here the power of z plus 3 is 1, means we get n equal to 0 in the Cauchy's integral formula for derivatives. Means here this integral is of the form f of z divided by z minus a dz is equal to what? 2 pi I f of a, right? So therefore here 2 pi I f of minus 3, because here it is z plus 3 means a equal to minus 3 and a is equal to minus 3 and the value of radius is 4. So minus 3 is less than 4, hence the point lies inside the circle. Then we can evaluate the value. Then f of minus 3 is equal to what? Already we know that f of z equal to 2z plus 1, then it becomes 2 into minus 3 plus 1, which is equal to minus 6 plus 1, that is minus 5. So therefore it is equal to 2 pi I into minus 5. This is the value of the integral, the first integral. Then second one, integration over c 2z plus 1 divided by z minus 2 dz, then it is 2 pi I f of 2. So here we get 2, since here it is z minus 2 and the value of a is 2 here. Then f of 2 is equal to 2 into 2 plus 1, because 2z plus 1 is there, then z equal to 2, which is equal to 4 plus 1, that is 5. Then now in equation 1 substitute these two values, the value of the first integral and the value of the second integral. Now integration over c 2z plus 1 divided by z plus 3 into z minus 2 dz is equal to minus 1 by 5 as it is, into value of this integral is equal to what? 2 pi I into minus 5 plus 1 by 5 as it is, then value of this integral is equal to 2 pi I into 5, because f of 2 is 5, then here we will get 2 pi I into 5, that is the value of the second integral. So 5 and 5 get cancelled, 5 and 5 get cancelled, here minus into minus becomes plus. Now 2 pi I plus 2 pi I, that becomes 4 pi I, which is the required value of the integral.